Back to our equation though. So we've got a little bit of a disconnect. We have a differential pressure and we've got a velocity. Can we go from one to the other? And this is a question where I'm stretching the HVAC folks here a little bit. And if we look it up, the answer is yes. I often assign this particular calculation question as a homework assignment for my students who are doing the VAV program, because it's a great one to send them home with at the end of a day and get them prepped for the next class period by looking up this equation. It's in almost all of our HVAC textbooks. You can do a quick Google search for it and you'll get specification sheets from, you know, a dozen different companies that'll give you the equation. But for our equation, velocity in feet per minute is equal to 4,005, that's a constant, times the square root of our differential pressure. Okay.
Yeah, so Robert, that's actually for pitot tube. That's for a single point measurement. If you've got one of these multi-point things in some of the VAV boxes, the number 4,005 doesn't typically apply. You need to look it up with whatever the manufacturer said.
Oh.
405 is for a pitot tube. It's for a single point measurement, 4005.
Okay, I stand corrected, and I will adjust that accordingly for my system. So you'll need to look it up on the documentation for your VAV box. For those of you who are using or creating your own boxes, I'll be honest, I don't know what number to use for you.
Yeah, sometimes you have to derive it, and that's an interesting lab exercise to do with your students also if you have a TAB class.
Good to note.
You can actually derive that by taking some measurements.
Fantastic. Thank you, Hadley. For the purposes of this workshop, even though it is the incorrect equation, I'm going to push forward with this 4,005 number, just because it's easy. It's not correct. I'll acknowledge that, but just to keep us moving forward. But we do still need to do this square root function. So let's jump back over to CPT and find square root. Okay. By the way, in CPT, anytime you have one of your libraries open, you can filter your results. So if we're looking for a square root function, maybe we type in square. Nope. How about root? Nope. SQ, nothing. So that's trouble. So how are we going to do a square root if we don't have that block? There's a solution to that because the contemporary control system doesn't actually give us access to a square root function. EasyIO does, so we're going to do that one first. Okay, and it's all involved with installing a new library, which is a basic task in the EasyIO system. Contemporary Controls has most of the libraries installed already, but there are a couple you can still install. Okay, and this is a very important task. We're going to do it a couple of times today, doing different libraries. Come on, chat. All right. So what we're going to do is we're going to double click on this top level EasyIO FW number. And you should get this window. This window is called the Kit Management window. Okay. And you can see this is the list of all of the libraries or kits that we have available to install in this controller. Okay. The ones with the check mark up at the top are the ones we already have installed. The ones unchecked are the ones that we have available to install. Okay. Some of these more advanced kits will rely on other kits to get their functions done. And may tell you when you select one that you have to install multiple kits to make this actually work. And do you want to do that? And the answer is always yes. So we've got this whole stack of kits here. And if we read through the names of them, there's a pretty good chance that we'll be able to figure out where our square root kit is. But if it's something less obvious, something that doesn't have an answer like the math kit, go figure, maybe we need to find that kit somewhere else, okay? Because, and we will run into this probably numerous times before the end of the day. So I want to show you an easy way to find the block that you are looking for, okay? And it relies in those files that are up on the Google Drive, those FW file folder.
Robert, can you take a step back and show us where you got that list from?
Sure, absolutely. So I'm just going to close. So I'm back over in my program editing area. I'm going to come up to my navigation tree, and the second line down says EasyIO-1.0.45.0. We're going to double click on that entry, and that brings us to our kit.
Thank you.
So I'm going to change my screen share to my PDFs. And one of the PDFs that is up on the Google Drive is the Sedona Kits for FW Series User Guide. Okay. Pretty descriptive name. Sedona Kits are going to be our libraries that we're talking about. And this has a really good comprehensive, or mostly good, comprehensive list of all of the blocks that we have available to program this controller with. And this is probably the best resource I can give you, Carlos, as far as how to know where to find a particular block besides practicing.
Yeah, thank you. That's a good one. Appreciate it.
Okay. There is an equivalent kit or document for the contemporary controls that I also put up on the Google Drive under the contemporary controls files folder. But this document, either one of these documents, this is contemporary controls document is 82 pages, and the EasyIO one is 174 pages. And the index up here at the top is useful if you have an idea what you're looking for. If you don't have an idea what you're looking for, though, you only know a keyword. So for us, square root. Use the find function in your PDF. Okay, Control F or file find or something like that, edit find. And I'm just going to look for square root. Hey, look, there's a square root function. Square root, or SQRT for short. And that is in the FW math library. So if we had any doubt what library we needed to install to get square root, then here we are. So I'm going to switch back over to CPT. Michael points out an alternative way to get to our kit management, and that's clicking on the gears up here on the toolbar. My double clicking comes from having used this programming tool from its early days when they didn't have that. So I'm going to come down here, find my FW math. Contemporary Controls, or some other company. The ones that do not have a manufacturer's name, it means that they were written by, as the core code for Sedona, or written by the company who originally made it, Tritium. But Tritium, I think, only ever wrote one non-core kit. So, but down here on my EasyIO FW Math, I'm just going to hit the check mark to tell it to install, and it's going to tell me what version it's going to install. And I'm going to hit apply down at the bottom. It's going to take the code and smash it into an understandable and digestible piece for the controller, and then shove it down the controller's throat. The controller will then restart and will automatically reconnect. And I should have warned you before we did this that you should save, because since we're restarting the controller, anything that wasn't, or that you did since your last save, will be lost. Sorry, I normally think to mention that one, but not always. So if we look down in our library now, we now have that EasyIO FW Math library, and we have more math than most of us probably care to deal with. We've got all kinds of trigonometric functions, log functions, all kinds of things, powers. But the one that we wanted, of course, was square root. Okay. Square root, of course, pretty simple, just has one input, one output. So if we take our 0.25, our square root is 0.5. Okay. That gives us that square root value that we can use. Okay. Make sense? All right. I'm not seeing any questions in the chat at the moment. Thank you for your continued input, Michael. I do appreciate it. So we will move on off of our math topic. Okay. In traditional programming systems, one of the most powerful functions we have is a statement called if, IF. And it's usually used in combination with then. I see your message, Brad. I'll catch it here in a minute. So if, IF, just the same as an English word, we usually pair it with if, then. Okay. And what if then statements do is we're testing a condition. If switch is on, then turn on lights. Okay. Pretty simple, pretty straightforward. And in traditional script-based programming, it's often as easy to implement as that. Not usually that high level of an English, but sometimes it is. And we can do that for statements along testing math as well. If x equals 10, then y equals 3. No, there's not a reason for that. Those are just numbers that I pulled out of my head. Okay. So to do that with block-based systems, life is a little bit different. We're going to use a couple of different functions to do that. The first one we're going to look at is CMPR, which is short for compare. That will give us the if ability for math comparisons. And more advanced, we could also use the Tstat function, which gives us some additional functionality. And we can also use SW blocks or switch blocks. We'll start with a compare block. So compare is going to be in our control library. and it's CMPR. Okay. And you can see for our block, we have two input values, X and Y, and we have three true false Boolean outputs. XGY greater than, XEY equal to, and XLY less than. So if we change our X value to 10, Y value to 0, we get a true on greater than. When they were both 0, we had a true on equals to. Okay, straightforward, as simple as that. So this might be useful when we are looking for a specific result or for two things to equal out in comparison to each other. Temperature and set point, for example. Okay. Compare. Pretty easy, pretty straightforward. Not amazingly useful for us because it does not have a deadband or a differential built into it. If you want that kind of functionality, you have to use some math blocks external to it to get that to show up. And for the most part, we don't need to because somebody was very nice and wrote us a function called Tstat, or a block called Tstat that has differential built in. And we can switch it back and forth between a heating system and a cooling system. Okay. We'll talk more about Tstat here after a while. But be aware that it's there, and it's probably the one you want to use anytime you think you want to use compare, or at least think about it.
So,
And the other,
so Robert, can you put together a bunch of these blocks and then somehow group them and make a higher level block? Is that how they did Tstat?
no, Tstat is, so yes, you can do that within Sedona, or you can do that with Sedona, but not within our programming tool here.
Okay.
There are some things that we can do to reuse code, like, which is what I think maybe you're getting towards. But to do it exactly the way you describe, it's an external function.
Okay.
The way they wrote Tstat is it is a script-based code. For anybody who has worked with the Niagara R2 system, the script code behind these blocks is very similar to Triple, which is the programming language that R2 used. It's kind of a hybrid between like C# and Java. And yes, that sounds absolutely horrible, but it's not that bad. It's more on the C# side. The other one that we wanted to talk about here was our switch blocks. And we have to know what kind of data we're working with our switch block, whether we're talking analog data or Boolean data, because our switches are going to be ASW and BSW. Okay. ASW switches between two analog values using a Boolean input. BSW switches between two Boolean values using a Boolean switch. Okay. So an example for something like this is switching between a heating airflow statement and a cooling airflow statement. So if we had a value of 250 for our cooling and 300 for our heating, And anytime we had a heating call, our valve was open more than 10% or something, and we wanted to switch to our heating value, this is the creature we would use. Okay. There is a very high probability you will use multiple of these in your VAV programs. Okay. Our Boolean switch, or binary switch if you prefer, it does the same function except when we have two Boolean inputs. So maybe it's something like a vacation mode setting for your house. And instead of having the outside lights trigger off of a physical switch, you want them to change over to a time clock input. I'm reaching for something to compare it to so it makes some sense. Something like that. Maybe it's choosing between two Boolean inputs between occupied mode and unoccupied mode. Something like that. Okay. What questions do you have on those? I'm afraid if I try and explain more about them that I'll confuse you more. So I need some direction. Are we okay with those or need more or what?
Can you give us an example, like using the Tstat, just say the temperature is set at 76, and then maybe have a certain deadband or something of that
Sure.
nature.
So on our Tstat, my brain kind of defaults to 2 degrees for a differential. Let's say we're in charge of a heating system. So we're going to change is heating, which is where we're going to define that to true. And Carlos wanted a set point of, I think you said 72 degrees, right?
That's fine, yeah.
Okay, SP stands for set point. CV stands for control value or current value. So this would be where we would tie in our room temperature. So let's say it's 68 in our room, our zone. And our output here has gone to true. So whatever heating system, let's say it's a residential furnace, first stage heat turns on. Okay. When our set point or our CV change, say we warm up to 72.2 degrees, our output on the Tstat turns off. Now I know what somebody's going to ask. What about raise and lower? Ignore them. The code behind them does not function properly. It doesn't function consistently. So don't just use out.
So I'm a little confused. So the ASW gives you the higher of the two? The greater of the?
No, the ASW, when our switch is false, ASW will give you your first input. When our switch turns true, it will give you the second input.
Okay, all right. Is there a way from this screen to click on something to get that description you just gave me? Or do you have to go back to the manual?
You've got to go back to the manual.
Okay.
That would be really a fantastically useful function if we could right click on this and go to manual or something like that. That would be really useful.
Is there like a boilerplate type of examples of these logic blocks for different applications? Let's say you have a chilled water system with the VAV, with the reheat, kind of what we're doing right now. Where it's constant volume, hospital type of application. Do you have any boilerplate type of, that we could have as a resource?
So EasyIO has created, and Contemporary Controls has done this with their controls as well, has created some canned applications, some pre-written applications for things like rooftop units or air handlers or plant controls. So yes, those do exist. I will caution you that typically speaking, when a manufacturer writes those programs, they are frequently a little bit over-engineered. So when you're trying to use those as a teaching tool, or even if you're just trying to figure them out yourself, give yourself some serious time before you ever present it to students, because it takes some time to figure them out, especially with like plant controls and VAV controls.
Yeah, that was my next question. You know, our vocational education students, just like myself and us logical people, we learn more by example and more by doing. And so that's where I'm coming from.
Absolutely. And the doing part of this exercise comes tomorrow. I'm just trying to show you some specific blocks that I think you will benefit from, knowing at least that they exist, and can kind of play with them between tonight and tomorrow a little bit. So, and once you get into your programming, you'll definitely have application for many of these type blocks. So it's, at this point, it's really a challenging line to walk between showing you what's going to be useful without giving you my answers. Because what we're working on is a project-based learning experience. So I want you to discover as many of the answers as possible, just as much to see what your result is as for the learning experience.
Yeah, you're trying to avoid the carriage before the cart type of thing.
Exactly, exactly. Yeah. And with passing this much of the programming information in one lump sum to you, that's a really kind of challenging line to walk. So we'll see if it's successful or not. You'll tell me into tomorrow, I think.
Hey, Robert,
Gotta let them suffer, Robert.
Go ahead, Ted.
yeah, where is the manual for the CPT?
The manual is in the Google Drive in
It is.
the EasyIO files folder, FW files.
Oh, so it's one of these FW, which one?
You want the Sedona applications or Sedona kits, right about the middle.
Gotcha. Thank you.
Not at all. All right. So, any other questions on kind of how we get to implement if-then type thinking, decision making?
If not, can I think Sean was having an issue with loading the math tool.
Okay.
I don't know if Sean got that resolved or not?
So we didn't get it figured out yet. It's when he finds the toolbox, like goes in, double clicks on the top, goes to the toolbox and tries to add a module, he can check it, but it's not giving him the option to apply it. It turns red instead of black like ours did.
So that is a mismatch in firmware version. Let me swing back to my CPT and see if I can make that happen. So I'm back in my kit management. I'm just going to click on another module here. Notice where it says install version. If you click on that version, you can hit a drop-down menu. And you may be able to find one of those other versions and select it. And that red may go away and your apply should come back.
Yep, worked perfect.
Awesome. So that will be entirely dependent on whatever version of firmware your controller has in it. And if somebody wants to talk about updating firmware, we can do that as a separate topic offline, because that gets a little bit complicated, and honestly, it's a little bit dangerous if it's not something that you're familiar with. So for the most part, it's a leave it alone type situation. Thank you, Ted. Any other questions, concerns so far?
Okay, I'm in the PDF that you directed Ted to, and I don't see ASW. Am I in the wrong?
That, let me look and see. So that is a specific challenge. I will find the additional PDF. The EasyIO Sedona kits that I pointed Ted and the rest of you to is specifically for the kits that EasyIO wrote. So if it's one of the open source original kits like the control library, then we have to go to a different document.
Okay.
I have to find my copy of that document because it's one that kind of gets lost on occasion when companies decide that people don't need to know so much about those. I will get that one uploaded as well.
Hey, Robert.
Go for it, Bob.
Hey, no, does EasyIO have the same problem as Contemporary or one of those other ones? So if they save a profile with a different tool set in it to their controller, and then they go into it with the wrong profiles not added, it won't ever open. Have you seen that created yet?
Yes,
Okay.
that is absolutely the case. So what Bob is talking about is we just installed our FW math kit. If somebody walks up with a different computer that for whatever reason does not have that FW kit or FW library installed on their computer or available in the Sedona data folders, they will not be able to connect to that controller. And actually that's kind of a sneaky backdoor way for companies to lock other companies out of a given controller, is they can write a little library that has literally no use to it. But if they install it on their controller and somebody else doesn't have that library, then they can't connect to that controller, even if they have all the passwords and everything else. It's really kind of a dirty, rotten, no good thing to do, but I have seen companies do it. And unintentionally done it to myself too. So that is a great point, Bob. When you are installing kits, and this was going to come up later, but we'll talk about it now. When you're installing kits, only install the kits that you need.
Yeah.
Okay. Because if you go through Sedona, not the manufacturer specific, but Sedona themselves, put an upper limit on the amount of space taken up by all of the kits that you install on a controller. I don't remember what that specific limit is, but I have run into it on plant controllers before, and it's really frustrating. So only install the kits that you need. That way you are not wasting space on your controller. And you never know when you might need an additional kit later on. And if you've installed a bunch of stuff that you don't need, you may run into issues. Okay. It also does kind of inspire some creative programming on the technician's part, because if you need a certain higher level function, but you don't have space to install that kit, you may kind of run yourself around a long way path to create that greater function. Okay. And we'll talk about one of those types of situations here when we get to PID loops in a few minutes. So Steve asks a great question. If you run into that issue where you can't connect to a controller because you don't have that kit, how do you resolve that issue? You have to pay attention to the error codes that are created when you first try to connect to that controller, and try and locate a copy of the missing kit. Here, after we're done with the main demonstration today, I'll do a side one for that, because that's a really interesting question. And I can, and I can maybe help you through that particular issue, Steve. Don asks a great question. Can you uninstall kits? Absolutely. You have to be careful when you're doing it. But let's say we install the FW HVAC kit. You know, one of those default ones. I'm sure we're going to need it, right? We'll install it. We'll wait too long to answer a question. We write our program. We end up not using anything from that kit. And I actually did this when I was writing my solution for the VAV kits, or the VAV problem. All you do is you come back in to your kit management and uncheck the box and hit apply again. Okay. And that will effectively uninstall and free up that space. That was a great question, Don. Thank you. Carlos.
Yeah, Robert, that was my question. Don got ahead of me. Thank you. Thank you.
And if you used a component within that kit, would you get an error, or can you not uninstall it?
Let's see, we've got the square root. It shouldn't let you uninstall it.
Okay.
But we will verify that right now. It's been a while since I've tried it.
Most excellent.
So we'll hit FW math. And there we go. SAP building error. Failed with one error. Unknown type in scheme, FW math square root. So it's saying when it builds it and compares it to the code you've written, it's got something called SQRT that it doesn't know what is. So it will not allow you to remove that library. That is a newer function. In the original Sedona stuff, it would let you remove the library and crash it, and you'd have to factory reset the controller. Not exciting. All right. Other questions? Been great ones so far.
So I know I keep asking questions, but I'm asking questions that my students are probably going to ask. All this is going to look Greek to them. So is there like an interpreter or something that like a flow chart, or I know this is kind of flow chart like, but something that's going to help them understand and not confuse them, if you know what I'm getting at.
I do. And unfortunately, that's going to be you. It is going to be the interpreter. I don't start students off with complex tasks like we are doing. I start my students off when they first see this program on the rooftop unit exercise. So they are taking over control from a local thermostat for a two-stage heat, two-stage cool rooftop unit. So that all of the work that they're doing with analog is all temperatures that they're familiar with, room temperature, set point, things like that, differential. And everything after that is just a digital control, on off. That seems to be a good intro to it. I've run this VAV project in one class so far, a second level class, and it went okay. Some students got it, some students needed more help. So.
Robert, is there a way to put notes in here somewhere?
So there is a note function down here in the bottom right. I'll be honest, I have no idea how it works because it is a newer function than what I'm used to. So I just created a note, logging out, logging back in.
I think a good point to make, Robert, is until we start experiencing programming from a group level, when we get into the groups tomorrow, you're really going to be just as lost as the student. So I think those questions, a lot of them will be answered tomorrow. And it's just by trial and error.
Yeah, I think you're right, Bob.
Just
Yeah, also, I want to add, I think the previous question, you just gave me a good teaching idea, which is what we could do is you could do a screenshot and then you could use sticky notes, from that screenshot to help explain to the student.
I'm going to yell at my student, Ted, tomorrow, and I'm going to tell him to delete all his stuff right at the end, just so he knows what it's like to come back from nothing and be a hero.
Sounds good to me.
And unfortunately, that does happen in the real world too. If a technician doesn't think to take a backup of a controller before they leave site, or the backup gets lost, those types of things happen, and somebody does have to come along and completely recreate a controller from scratch. Been there, done that. It's not necessarily a fun adventure.
Only for the teacher.
I have a quick answer for Carlos. It's probably not an easy answer, but one of the things I do when I teach the programming is I actually show Allerton Programming first, which uses Visio and shapes. So when it comes to like when I'm showing an AND gate, instead of having just a box that says AND, it literally has a shape of the AND symbol. If you look at boolean symbols, it's something that I have because I have access to the Allerton system. But as far as programming, you're actually showing shapes, and that helps connect the dots for some students a little bit more than just the boxes that say and, not, right?
Yeah, that's we're on the same page. That's what I was thinking, flow chart, and sticky notes and something that's gonna, interpret this Greek. I'm calling it Greek for the lack of a better word. So, because ultimately that's our goal, to help the students learn this. At the same time, we're trying to learn it. So we're kind of, in a sense, we're kind of in their shoes right now.
Mm-hmm. I mean, really, the best way I found is the other way is you kind of have to have the programmer's manual open while you're doing it. So I'm pretty good when it comes to Allerton programming. But when I start looking at stuff like this, is like, okay, I'm trying to look for a comparator. What's a comparator for this product? Or if I'm writing line code with Delta, it's like, okay, how do I do this with one product and try to translate to another. It's just kind of knowing the language. And that's one of the things about about controls is we're trying to teach a language.
Steve is 100% correct. It absolutely is a language. And one thing that you will find if you do this for any amount of time is you will learn whatever your first programming language is, you will learn that. And it will be challenging. But whatever that second programming language you learn is, will be 10 times as hard. It will not be easier, believe it or not, because you're used to the original language that you learned and all of its rules. And when those rules don't apply in language 2, it will boil your brain for a time till you get it through. Then after that, all the other languages that you will learn will be that much easier because you will know the overall idea of what you're trying to do. And you now just have to figure out how system X wants you to do it.
And it doesn't get any better when you're using open source stuff either, especially like BACnet. I tell people BACnet, having something that's BACnet compliant is like bringing in somebody from Australia and someone from the deep woods, the swamps of Louisiana, and then having a conversation between the two and trying to figure out what's going on. It's a lot of them talk. It's all English. It's all BACnet, but it's all over the place.
Dialects.
Yeah.
Yep. And what they choose to share and what they choose not to share, what they think is important versus what the other team thinks is important. Bob, you wanted to say something?
I was just going to say too, when you guys are programming this stuff, the blocks don't always function like how you would logically think they would function. And you need to pay attention to that because it'll drive you crazy too. And don't always trust the diagrams. They can be wrong too. Just like all the textbooks that are written for HVAC that are perfect, that have no errors in them, it's just like that, you guys.
Bob is 100% correct. Especially if you get into programming something and it's not acting the way the book says it should, or you think it should, take a timeout and experiment with it to figure out how it actually works. Okay? It's just like the raise and lower on that thermostat block. The way I figured out it didn't work was I was trying to use it and it didn't work the way I thought it would. And so I started testing it and found that it was inconsistent. So I just ignored that part of the block because the rest of it worked fine.
So one of the things that I noticed when I used to teach programming was that if you try and teach people how to understand it, how to figure it out, it's difficult, but in the end, when they run into these problems, they're much more they have a greater capability to solve them because they're too used to memorizing things. And so, I think this is the wonderful thing about the problem-based learning is they tend to figure things out and they're forced to do the critical thinking that's necessary. But once they start memorizing stuff and saying, no, I just want to write it down and then I'll look it up when I need it, you're cooked.
Exactly. As much, I don't know about you folks and what your advisory boards tell you, but one of the basic tool usages, my advisory board says that critical thinking and problem solving are right up there with critical skills like communication. They're more important than, learning a specific, programming tool or anything like that. So. All right. Think we've gotten a number of things answered there, and we should probably move on so that we don't run out of time before we hit a few critical items. Because we are going till 12:30 is our next break. So we've got some time, but. So our next object, and this is something that's pretty specific to, well, really it's not, it's pretty universal. Timing of things. Being able to delay the start of things or delay the turning off of things or making sure something runs for a certain amount of time before it turns off are really kind of important to us. So let's talk about timers. We're going to talk about 3 different timers. The first 2 are in your control library, and they are DLY off, standing for delay off, and delay on. Okay. And the verbiage is probably reversed from what those from the HVAC industry are used to, at least. We would call them on delay or off delay, usually in association with relays or some specific controller. Delay on is a stop and wait. So if we set a delay time in here of, I don't know, 15 seconds. By the way, both of these timers always count in seconds. Okay. So if we want something to wait 15 seconds before it actually starts, we use the delay on. Note your hold time here. No, that's not Zoom making a mistake. It just throws garbage out. It does not give you a proper countdown timer. That's what hold is supposed to do, but it does not. Okay. And you can see after 15 seconds, we turned on. I describe the timer functions to my students as middle management. You know, you've got the big boss, maybe a thermostat, saying, hey, turn the heat on. And the middle manager standing in the way says, okay, we'll turn the heat on. I got to think about this for a minute. Okay, worker, go turn the heat on. Something along those lines. They seem to get that reference reasonably well. Delay off, of course, works a very similar way. We give it a time. Of course, it turns on immediately. We turn off, and it continues to cycle. Sometimes we'll do this in association with dampers or valves that are tied to fans or pumps. So to give the pump or fan a chance to cycle down before we close off a damper and risk damaging our system. Okay. Pretty straightforward. Also pretty useful. Okay. Our last timer that we're going to talk about is a minimum run timer or minimum on-off timer. And that is also going to be in a library we're going to have to install. You will notice that we're going to install libraries several times just to kind of give you practice at it. We could have gone through and done them all at once, but this way tomorrow you'll have some practice doing this. So before I go to install my library, I'm going to save so I don't lose any of my changes. And I'm going to head back to kit management. And I'm going to use the gears up top this time. Okay. And the library I want to get this from or want to install now is FW control. Okay. And I just know that because I have it memorized. We could look it up in our document to find that function, but I showed you how to do that one once, and I know you're all intelligent people, so I won't insult you. But I'm going to install the FW control library.